Welcome to part 3. So it should be known that 96% of all scientific phenomena is non-physical, which includes gravity, magnetism, electromotive force, voltage, inductance, time, atomic communication, photons, quantum entanglement, which is the information to energy to matter, transfer, data to energy to matter. So we have quantum numbers in both quantum chemistry and physics to delineate quantum entanglement and spin rates, spin chemistry especially, and the morphogenic resonance. Feel free to study these principles. And so therefore 96% of all scientific phenomena that's understood is actually within quantum science. And so then if we go to the other 4% of all scientific phenomena, 4% of all scientific phenomena is physical, which includes mass, acceleration, classical mechanics, kinematics, sound, heat, force, statics, dynamics, and i.e. classical science. So if we look at the electron, particle, or particles, then we're dealing with the atom or two or more atoms, molecules, also known as chemical compounds. And then we have electron wave or waves. So we're dealing with atomic energy or molecular energy. So through quantum entanglement, atomic energy delineates into the atoms or the electron particles. So if we have one electron, we have hydrogen, 2 is helium. If we have 12, it's carbon, etc. So those are really verbal or literary nomenclature for mathematical electron count. Periodic table of elements is a delineation of electron count. And so we have the quantum entanglement that's occurring. So we have base materials, and that's the periodic table of elements. And then lastly, we have the wave particle electron, which is in its photon or magnetic state. The wave particle duality of light, or the wave particle electron. So the electron technically is both. It's probabilistic collapsing of timelines or events into particles, but the electrons are existing as waves. And so there's a correlation between human consciousness and what the electron waves will and will not do. So this was unbelievable or unrecognizable until the experiments in the double slit experiment were conducted, and then the observers, when they were absent the atomic computational or atomic observation, we'll say the atomic version of a camera had actually quantified what would be an electron particle was actually a wave until the human observers looked at that, and then it turned back into a particle. So we're dealing with wave particle electron physics, and that is the photon as well as the magnetism or electromagnetism. So all of those are the precedents to the physical state. In the next part, the reference pages, including the giants in both classical and quantum science, physics, and physical chemistry, quantum biology, will be referred, and these individuals, past and present, are worth studying and reviewing their work to get a better handle on potential practical applications in quantum mechanics. See you in part 4.